Well, I'm gonna do something that's probably the most bold move of my life. I'm gonna do this talk live coding in the text editor. And, well, let's hope I don't screw up so bad. First, who am I? My name is Milhouse, but some people call me Renan Ranelli. Like everyone in Brazil calls me that because I'll just show you a picture. I'm a senior software engineer at Sherpa. We're a startup in São Paulo. I work primarily with Elixir and CleverScript for the past 2 years. Sorry about my voice. I was in Zach Wild's show. I kind of used it. I kind of left it there. So, why do people call me Milhouse? Well, that was me not so long ago. And they say I did look like Milhouse, but, well, I had hair. So, the problem, what we're going to talk about here today is some knowledge from the trenches. We have a very big Elixir application, and we needed to wrestle with the recompilation behavior of Elixir, and it seemed like no one had those kinds of problems before. I have personally spoke with José Valim about them, and he said, wow, you guys got a lot of code. Interesting. So the problem is we change a module and end up recompiling other seemingly unrelated modules. This takes a lot of time and breaks our flow. To show you what's happening, I'm gonna open. This is some of our code. And okay, everything's compiled. Now I'm gonna change one line. Okay. I'm gonna compile again. And this happens. And this sucks. Today I'm going to try to tell you people, why this happens and how to avoid it. So, Elixir is a compiled language. That's why we're talking about recompilation in the first place. Elixir relies heavily on metaprogramming, which is basically code interpolation. And when you generate code, it's like you're statically linking code. Like it's a problem of static linking versus dynamic linking. When you're just calling code for another module, nothing needs to be recompiled because everything's dynamically linked. When you're generating code, you need to recompile stuff because generated code is statically linked. So, what does that mean? How many of you guys how many of you people, are familiar with metaprogramming in Elixir? Okay, so I'll just do this kind of fast. Well, metaprogramming is like, we had a talk today, it's like interpolating code, right? Like interpolating strings, but with code. So I'm gonna write this, well, I'm just gonna copy and paste this thing. Well, let's go. It's kind of laggy. It's making me nervous. So we're gonna write a macro called macro, which will only add 1 to the article, right? So I'm gonna open a REPL here, and there it, oh, damn yellow thing. So we have a macro here, which we call macros.macro with 1. Oh, right. Yeah, it should require the thing. And 2, 3, 4. Okay? So in order to see this a little bit better, I'll do something that you should always do. which is return the quoted expression from a function. And why is that? Oh, I'm gonna, oh boy. It's laggy, weird. I'm gonna show you in a moment why. Plus 1, wow. Plus 1 of x. Plus, no. Ah. Plus 1, okay. We evaluate again. Why is that? Because then we can do this. We can call plus 1. And we get this weird thing. This is Elixir code represented as data. And what we can do with this code, we can call macro.toString, just actually see the code we are generating. So the body of our module is actually this, 1 plus 1. If we change 1 to like lol. So this is basically code interpolation. That's what metaprogramming is all about in Elixir. The thing is, if we were to change the definition of this macro from plus 1 to like 2, what needs to happen? All the modules that use this macro, that generated this code, need to be recompiled in order to be consistent with the new generated code. And that's the reason why we have recompilation. Right? Oops, sorry. There we go. And I just want to point that Elixir, and this is one of the points where Elixir and Erlang differ the most. In Erlang, the only reason to recompile something is when an included header, like an HRL, people tend to put record definitions in those files. When one of those files changes, and the Erlang compiler has the -m option that generates a make file that will recompile things for you, and you don't even have to think about that. That's why if you look in the internet for Erlang recompilation, you'll probably find nothing. And in Elixir, all things are much more complicated because you can execute arbitrary code while you are doing the macro expansions, and that's what makes Elixir so powerful in the first place. So, what I'm going to do here is I'm going to write a bunch of code, and then I'm going to compile stuff. And the name of the files that I'm going to show, I'm going to write here are here so that you can kind of see what's happening. So I'm going to write that module again. The +1 thing. Oh, it's I can't deal with not indenting. Sorry. There it is. And I'm gonna write a module that uses this macro. I'm gonna call it uses macros. First thing you have to do is require the macro module, and this tells the compiler, well, I need that module to be compiled so that you can compile me. This is the first moment where a compile time dependency is created. And we're talking a lot about that. So we're just going to call the macros +1, 1. Right? So I'm going to compile stuff. And then, what happens if I were to change this to 2? Well, when I compile, oh, we can't see that yet. Oh, okay, but when I compile this, we need to be regenerated. And, oh, shit. I'm nervous. How do we find out? As we could see, there's no way to tell what got recompiled here. So how do we find out what is being recompiled? We need a mechanism to validate our hypothesis on how recompilation behavior occurs. Prior to Elixir 1.3, the compiler would output a line for each file that was being compiled. So our life was kind of easy. Since we live in the future, we need to find out for ourselves what is being recompiled. And we're lucky because there's a tool called iNotify-Wait, which is available in most Linux, and I think it's available everywhere, where we can watch the file system and tell which files are being written. And there's some magic shell incantation here that will show us exactly what is being recompiled. So what I'm going to do here is I'm going to run this magic incantation. And just a second so I can set up the... Okay. So when we recompile something, we will see it down here, right? So let's go. And another great thing is the xref tool, which actually tells you all existing dependencies. So I'm gonna go to that big project, our whole project. Oh, let's just finish it compiling. And we call mix xref graph, and it will show you all of the dependencies, and you are free to look at them, which is quite hard when you have a big project. But it's quite useful, and we'll look at it in a short. When compile time, and I'll give a quick example what means this output. You get what file depends on which other files, and as we can see, this controller depends on the authorization module as a compile time dependency, which means if this file changes, the controller will be recompiled. And the same for all the other lines. This is a runtime dependency, so that means if this file changes, the controller will not necessarily be recompiled. Right? That's how you read the output of xref. When you import or require a module, you will automatically create a compile time dependency, as we have seen in our previous examples. The big catch here is the transitive compile time dependencies, which are not shown by xref. If you have A, which depends on B, compile time, but B depends on C, runtime, if C changes, A will need to be recompiled. That's the biggest catch. If you're gonna take something from the stock, remember this. And I'm going to demonstrate why that is. So I'm gonna just define a module A with the function A that we'll call a macro in B. So we need to require B. And in B, we're going to define a macro called macro, because I don't have that kind of creativity. X. And we're just going to do x plus 1. Right? And then we're going to whatever it just calls C, because C is a runtime dependency of B, and for C, just return 1. right? So just let's get those things. File, let me open the see. Oh, sorry. There are some more stuff here that I prepared. So don't worry. When we change C, oh come on, please work. Don't do this to me. Which file am I at? Oh boy, I'm nervous. Why is this not fun working? Oh, please work. Notify. Okay. Oh boy. Just I'm live debugging. That's terrible. Stagling to transitive. Lib transitive. C. Okay, the code is there. Why is it not working? My change is there. Oh. Maybe? No, there's no need to require C and B. I need to require... Oh, the thing is compiling, right? Oh, it's not. That's why. Oh, thank God. Oh my God. Oh, where is it? I should just copy it. Oh, that's here. I'm stupid. Sorry. Oh boy. And the final function. Where is it? Oh, I didn't tangle the thing. That's fine. Oh, Jesus. I've never been this nervous before. So, yes, there it is. If I change B, oh, thank you. B gets recompiled, and A gets recompiled, right? Because B is a compile time dependency of A. If I change C, well, C gets recompiled and A gets recompiled, right? I'm not lying to you. But why that is? That was the thing that baffled me the most when I was understanding this. The thing is, B can execute arbitrary code when doing the macro expansion. So we can do something like this. If C.C is bigger than 0.5, we return this quoted expression. Else, we return, oops, this quoted expression. Which means if we change the definition of C, even if C is a runtime dependency of B, the code generated by B's macro will change. So we need to recompile C, B, and everyone, C and everyone that included B. That's the reason why those things happen. And if I were to change C, we can see C is recompiled, A is recompiled. Right? So let me just get a bigger. Okay. That's the big catch. Also, when an alias is seen by the macro, a compile time dependency is created. Oh, also, we can see the the xref here. Oh. Xref graph. And we can see that there's other things there. That A depends on B as a compile time dependency, but C is a runtime dependency of B. That's how you get to use xref to understand these things. And inotify is giving us exactly what is happening down there. So we're gonna write a module that sees A in its macro expansion. And that is, I'm gonna call it CA because it sees A. It's gonna have a macro that does nothing at all with A. And returns 2. Right? And then we're gonna write a module that uses CA. Require CA. And we won't actually need to do anything here. So if I change CA, then CA and uses CA gets recompiled. But if I change C over here, and as we remember, C is right down the chain, the compilation chain, the dependency chain. We see that C is recompiled, A is recompiled, uses CA is recompiled. So that's how the dependencies go way, way, way. Look, there's a big chain of dependencies. But as you can see, we did nothing with this. We only got attributed A to a variable we didn't use. The compiler has no way to know if this A is going to be used for something, if it's going to be used to generate code. So it creates a compile time dependency nonetheless. And this is one of those tricky problems. When we use struts, how much do we have? 60 minutes. Well, I'm gonna speed up things a little bit so we can go to what matters. Not so lively anymore. So, well, we define a struct X with a field X, and we define a module that uses X. And what happens if we change X? Oops. Well, uses X gets recompiled, and X gets recompiled. And why is that? When we write a struct with this syntax, the compiler checks that we are not using a key that doesn't exist. So if we try to compile this, oops, I forgot to export it again. We'll see that it doesn't compile. If the definition of the fields change, we need to recompile everything to check that everything is okay. So back to the notify. If we change X, oops. Oh. Probably it's not compiling anymore. Oh, come on. Oh, it's that one that I forgot. okay. Everything's gonna be fine. If I change X, both get recompiled. But you can get around this by giving up those checks and just writing the plain strut like this. So again, if I do this, only uses X gets recompiled, and if I change X, only X gets recompiled. So that's one of the ways you can get around this behavior. And the big kid on the block when using protocols. I'm not gonna write that live because we don't have that much time, so I'm just gonna copy it over. So we have a protocol definition of protocol. I always wanted to write that. I finally had the opportunity. And protocol defines a function called function. And we are going to define structs Y and Z that will implement protocol for them, right? So what happens if I change the protocol definition? Well, we need to recompile every single implementation, because how do we know, for the same reasons as the structs, if I change the function name, oops, again, oh gosh. If I change the function name, we need to update the implementation so that it can reflect what the protocol actually does. And also another thing to comment about protocols is when you use protocols, you write something like this: protocol.function, and then some data. This function is actually a plain Elixir function, but the compiler does some magic to generate this function body based on the implementations. And this magic is called consolidation. If you define an implementation for a protocol after protocols have been consolidated, this function will not see it. So when you're on IEX and you try to define some implementation there, maybe you won't see that implementation reflected in this code generated here, because the compiler already gave up those dependencies. And if I change the implementation, only the implementation file gets recompiled, and the module that defines the implementation gets recompiled. The protocol itself is not recompiled, unless you do something stupid. For example, in the same file that defines the protocol, you define a module that holds a dependency on a file that depends on the protocol. If we do that, we will see everything being recompiled. And if we look at xref, we're going to see something cool. We see protocol, depending on protocol itself. So everything that reaches protocol will also be recompiled. That's a cycle. That's something we don't want. We don't want cycles, and those are the reason why we seen in the very beginning of the presentation 200 files being recompiled, because we changed only a single view module. and you don't want that. And you probably won't have cycles if you have good design. But this is the same as saying, don't create bugs. Stop writing, oh, I have so many bugs in my application. Well, stop writing them. That's not how it works. So if you're in this dire situation, how do you get out of it? Well, first, don't require or import things needlessly, which is like have good design. And how do we identify cycles? Well, remember that 240 recompilation we saw? We're going to solve that. So, oops, sorry. Let me close that. So, I'm going to run the XF graph. And we're going to see something interesting here. Oh, there's a, sorry, get out of here. So the file that we changed was, that's one. Well, sorry. That's the file that was the problem. And xref gives us the sync option that will show us, oops, you need to give the weird path here. Oops. It will show that the sync option should show us, oh, come on, please. Well, I know where that is, but I wanted to show you how to find it. So let's go to the villain itself. See, this is the big cycle, and it begins with the router. But the router is depending on compile time on the second line, the schema.ex file. And that shouldn't happen. But why does it? Oops. There you go. Schema. That guy is being seen by the macro expansion. There's nothing that this module actually generates. So how do we solve that? Well, there's the dirtiest trick in the book is the module concat function. The module concat function will take strings and create an alias, like this, the foo and the bar, and create a module foo and bar. We're essentially going to tell the compiler, hide the module from the compiler. For example, remember our A, B, and C examples? And now what we're going to do, we're going to call motsi a C, but not like that. We're going to module concat C. Call motsi.c. And this will break the dependency. Oops. Right, I notify again. And now if I change C, only C gets recompiled. Right? So we broke the cycle, but we are using C to generate code. if I were to change sys to -1, not this branch would execute, but this branch would. But since we are not recompiling things that include B, though that code, that generated code, will be wrong. So if you want to call module concat, only do if you really need it. And now, if we get over here, and we do that dirty trick, here and here, which are the two places where this happens. Since we changed the router, it's going to take a little bit of time to compile. And as you can see, by only changing the router, 236 files got recompiled. Only 2 files differing from that when we changed the other file. So let's wait until it's done. And we can go back and change that file. And that's the kind of situation we got in a year ago. Every change we did to the code base would require almost 2 minutes of recompile time, which you don't want. Okay? So if I now change this, oops, just click. I redid the change, and I compile again, it's done. Right? So we broke the big vicious cycle. And most of the problems are things like that. There's like one point where it creates a big cycle. Okay. We did that. And there's another dirty trick. Not dirty. Is to disable the lexical tracker. And there are 2 pull requests here. Oh. Okay. This was my first attempt to contribute to Acto, because Acto had every relationship you declared in Acto would be a compile time dependency. And since we have more than 80 of those, every time we change any one of them would recompile the whole thing. So I talked with Jose himself, and he said, well, we need a patch. I tried to write a patch. I wrote like 200 lines for this. But someone that knows his shit came and did a patch with like 8 lines. And, well, I was angry and impressed at the same time. And the trick is to control the macro expansion by disabling the lexical tracker. But don't do this at home. Don't do this unless you really know your shit. Which I don't recommend you to. So if you ever come to a situation where you need to control those things, probably having a look at those pull requests will give you a hint on how to proceed. That's all. Thank you.